Hello, everybody, and welcome to our fifth session, information visualization. Today, we are going to discuss one of the best practices in visualizing health data and how we can approach this. And basically, we are going to be integrating the four previous session into practical elements and create a reflection about that and show you some interesting tools that we can use in that regard. Then just to refresh our memory, when we talk about information visualization, even though we have been talking about that information is created by our brains, is the idea to create interactive visual representations of that data that is going to convey information that we are going to having advantage of how human brains perceive the world and how they process the data and the information in order to solve problems. In that order of ideas, we need to refresh the concept of data, information, knowledge, and wisdom. And remember that data is that observable measurement thing that in some way we need to store and we need to manipulate and transform in order to create that visualization, that representation that the brain is going to be able to interpret, to extract that information, to convey that information, and be able to continue in the cascade in order to provide to build the knowledge and the wisdom. And we know that data is collected in multiple ways, and they can be collected as questionnaires, they can be collected as an interviews, they can be collected as an observation or analysis of documents. Nowadays we have computers that can go and scrap the web and create huge amount of data just for artificially reading documents. We can have matching measurements like the lab measurements or the different devices. And when we collect the data, then the next step is, hey, how do we organize that data? What do we do with that? And remember that raw data is the form that we basically receive or we collect that data. And we can do that on paper, we can do that electronically, we can do that as voice recordings, as a video recording. Raw data can have so many ways in healthcare. But then we need to deal with how we store it and how we transform that. And if we are collecting data in some formats, then we may be storing that data in that format. And we need to be aware that when we talk about data storage models, we are talking about databases. And not every single database is the concept of electronic database. Think about this as when we used to have the yellow pages, that book with the phone book with the companies was a database of companies, of services that was organized by the type of service, and we just query the book through the index and through the different marks that we have, and we were able to retrieve a business that was offering services that we were looking for, and we have the address and we have the phone number. And that same apply for the phone book or the directory of people, the white pages and so on. And that was a database. Technically it's a database because it's a way that data was organized, that was stored and was able to retrieve. The common ways that we have to store data are tables, and if you think into the yellow pages, it was not a really table, but was a model like the hierarchy that we have, the type of business, and that hierarchy then it follow a predefined order that was the alphabetical order of the name of the business, and that was the way that we created a hierarchy. But we can have tables, we can have relational models, and we are going to talk a little bit about that. But basically, a relational model is tables that are linked in some way. We can store data as an object. And an object is just that representation of a type of element, and it has a series of attributes, and I can relate with other objects, and they have something that we call methods and how they relate one thing to another. We have the hierarchies, that the example that I provide you with the yellow pages, and we have ontologies that basically we are correlating data by their conceptual meaning, and is when we have semantic networks and we have a little bit more of complex representation. And healthcare usually is represented and can be represented as an ontology, and we are going to study that a little bit in deep in future classes. Then that said, those storage methods are going to inform us how we can use the data and how we can visualize the data. And here we have some examples of data storage. We can have data storage that is column oriented, or we can have a data storage that is row oriented. And where we are talking about column oriented is basically, as we see here, that the variables are organized in columns and our units of analysis are organized in rows. When we have row-oriented data observation, we are going to have different effects. In this case, our observation is the score for individual subject, and the variables are the other ones. Then we are changing the organization, but we can see that the individual in this case is not every single row. And then if we want to do an analysis that is associated with an individual, we need to do additional transformations, because every single individual we see here that they are repeated, and in this way the observation is basically the score for a subject for a particular individual. And this representation can be really useful sometimes, and we are going to see that when we start doing the tutorials for visual representations in the future class. But we need to understand that the way that we organize data is going to give us different functionalities, and that's one of the first tasks that we need to really accomplish, and is to be able to transpose or organize data. Then usually in healthcare, we organize data in column-oriented format, and where every single row or every single line across the table represents the unit of analysis. It's going to be a subject, it's going to be a borough, it's going to be something that we call the unit of analysis is going to be across the row. And the columns are going to represent the different variables or the observations that we are having about that work. Sometimes we have multiple independent variables, as in this case agency and boroughs. They could be independent variables. Then defining what is our observation unit could be challenging sometimes, but it's something that we need to start defining from the design when we are doing that. But if we want to organize data, then we want to have each variable in one column. Each different observation is going to be in a row. And if we have different kinds of type of variables, if we have categories of observations, or we are changing the observation, actually we have different type of unit of analysis, then we are going to create a table for that type of unit of analysis, and then we need to create a way of linking or joining those multiple tables. When we have that kind of observation is when we enter into the domain of that relational representation. And this is the same data that we were presenting about the student scores in a relational representation. Then we have a table that is dedicated for the schools. We have a table that identify our students. We have a table that identify our classes, and then we recreate a table where we have students class and the grade for each student in each class. But then we have another relationship where we associate every single student with the school that they are attending. And here is an error. It should be 1, 2, and 3 to represent every single student. In this way, we can even see that there are other type of questions, different questions or different filters that we can create that the same example, tables are not facilitating that measurement, and in some way we can avoid repetition of data, like for example the gender. We don't need to repeat the gender. That's something that we know that student in every single observation in a table, or we don't need to repeat the school name where the student is attending in every single observation. Then we can simplify in some way the data representation in this relational representation or format. And it's the way that usually we think about databases and computers. But it's not the only way. But the important thing is when we have that representation, that data, we need to understand that information is essential part of human life. And you have this article that you can visit in the materials, the week materials, that is going to tell us about different methods and interactive mechanisms in order to create this information visualization. But definitely we want to extract valuable knowledge from the data that we have collected and the information that is available for us. But this is a big problem. And the way that this article presents this is, and we have been talking about that, is hey, we need to have a clear mapping concept and on activity. Then basically we need to know how to visualize information and how we transform that information or that data into a graphical representation. And we have been showing you some of the initial elements, and we have introduced you the different type of charts, the different type of data, and the different type of question or tasks. And we have been discussing how the task is going to inform the type of data that we need, and the type of data that we have available is the one that is going to define the type of visualization that we can create with the data. And then we need to select the different ways that we can represent something and present and organize effectively this. And this selection and representation has to do with the question that we are asking and how we tell stories. Is how we build a story and how the interactivity is going to modify the way that the user experiences the story. And something that we cannot forget is that we are humans. And then take into account usability and, most important, accessibility factors that we have been introducing as well. We need to test our visuals for accessibility. Is the font readable? Are the colors well contrasted and things like that? And then, of course, we always need to have that evaluation portion in order to be able to have have a retroalimentation or have a feedback in the way that we are doing. And do you remember this graph? No. And that's this document from the WHO is going to be one of those that you need to be referring. But the first question is, what would you like to show? What is your task? No, do you want to show a relationship? And as we see, the best practice to show relationships are going to be the scatter plots in the case that we have two variables, or the bubble charts when we have three variables or more. Why do I say more? Because remember, if we include color, then we can encode a fourth variable in the color. What are the three variables? The x and y are going to be the first and second variable. The third variable is the size of the bubble, and if we introduce a fourth one, is going to be the color of the bubble. In this way, then we can see relationships between observations and see if there is a correlation or a linear relationship between the variables that we have in the x and y, or what kind of a relationship we can infer from that. Then if we want to compare, then remember that we want to compare things among items, or we want to compare things over time. Is time one of our variables, or are we comparing nominal or ordinal or categorical elements? If we are Then comparing categorical elements, we are in the left. We are comparing things that change over time. Then we are on the right. And these are not the only relationship, the only comparisons that we can do, but are the more common. Now, if we have two variables per item, then we can have a column chart that has variable width or a variable height. But if we have one variable per item, but we have many categories, we can have a table or table with embedded charts. And remember, this is the small multiples as well, that we can have that, and we have repeated a representation of that item, that variable, over the table that is distributing that. We have few categories and many items. Then we explore the bar chart, and the bar chart is really useful when the categories are ordinal and you can see some kind of a geometrical distribution that you want to highlight. And we can also have here the violin representations and these other representations that basically are representing shapes, that the shape is telling us about the behavior of the observation. And when we have few items, then we can have those column charts side by side, but we still need to ask ourselves, is this answering our question? If we are over time, then we can think about, do we have so many periods, or we have a small periods of time? If we have many periods and we have cyclical data, maybe we want to consider a radar or circular area chart to represent that, and every single period is going to be one of the circles or cycles that we complete in that area chart. And if we have non-cyclical data, that basically is a timeline, then we can use the line chart to represent the variable if the second variable is a numerical or an ordinal variable that we can put in an axis. Because sometimes we are going to have time against things that are not numerical, then we cannot create a line, but we are going to have the timelines that we introduce in the practical exercise. When you have a point of time where something starts and a point of time where it finishes, then you can represent that in a graphical line. We have few periods, then we can use the line chart, the column chart, depending of what type of comparison we can do. We want to make among the different categories. Distribution is to show how something follow a pattern, and then we have a single variable and we have few data points, or we have aggregated data points. Usually we have a column histogram that we are aggregating the data in some buckets. But if we have many data points and we can have a linear distribution, then we can create a linear histogram that basically it's a representation of that density of data function that we have there. You have two variables. We can also use the scatter chart, and then we are going to see now not only the shape of the new figure, but how far the elements are, and we can identify here. This is really useful to identify outliers, and we have already presented the utility of the scatter plot in order to identify outliers or to identify clusters. That's going to be really important. And when we are identifying clusters, then we are in the domain of the relationship or a distribution. If we can identify a third variable that is going to be our classifier, then we can analyze the distribution of those clusters. And we can create compositions of multiple observations and utilizing some transformation. And remember, we also have these other functions, that distribution, correlation, ranking, paragraph hole, evolution, map, and flow. And in that class, we introduce some of those cool visual representations for every single of those. But today I want to focus in this visual mapping. Actually, this visual mapping is a product by Ralph Legner and Martin Epler. They have this website that is called thevisualliteracy.org, and they created this visual representation, this visual map that they call the periodic table of visualization methods. And this periodic table of visualization method, as you see, they divide the visualization methods in different categories. Then the first category is just pure data visualization, is the one that we just review, where we have the table, the Cartesian coordinates, the pie, the line chart, the bar chart, the alia chart, the histogram, the scatter plot, the box plot, and the spectrogram. A continuum is just an arrow that represents changes or elements that you represent in that arrow. The table by itself is the one that we introduced, that the table is how we collect data, how we store data, but also how we present data sometimes. And you are going to see that tables are going to be in a lot of our publications and visualizations. And tables are really useful to look into particular values and to highlight differences when we are already have made some comparisons. The Cartesian coordinates, this is really useful to create clusters or observe how are the dynamics of things. And we can use the Cartesian coordinates in healthcare, especially for risk assessment. Then we have the two variables, and then usually the higher risk are in the right, and then we have the combination, and the lower risks are on the lower left, but the interaction of the variables are going to put us in different location or risk representations. It's also used to represent in the informatics domain maturity levels and acceptability levels. When we have those, then we want to have the preferred things in the right upper quadrant, and we will see a lot of visualizations that things we want to have that in that element. The pie chart, the line charts, we have discussed the bar, the area, and this is a violation. Remember that 3D representation is not the best way of representing data. Histograms, scatter plots. This is one that we haven't discussed that much, a spectrogram, but we use a lot of spectrograms when we have signals that are repeated over time, or that they follow some frequency, like the heart sounds or the electrocardiogram or the electroencephalogram. We can do a spectral analysis of that, or we can do a spectral analysis of the voice. And there are a lot of research right now, for example, to identify if a spectral analysis of the voice allows to identify the mood of of people, and just the spectral representation of the voice is going to give us some patterns that basically you can identify. Oh, that voice is a voice of somebody that may be sad, or that's a voice of somebody that is happy, and those are kind of interesting. But today we are going to be focused on information visualization, and as you see, they say that information visualization is the use of interactive visual representation of data to amplify cognition. That we already introduced that. That means that the data is transformed into an image, is mapped to a screen space, and that image can be changed by user as they proceed working with it. Then change by user is telling that information visualization is defined by interaction. Okay, that's the first thing that we need to take into account. And the second group of visual methods is the concept visualization. Then they say that these are an evolution of that information visualization, where the user elaborate qualitative concepts, ideas, plans, and analysis. Then basically we are in the domain of visual analysis. We are taking that information into another level that by the interaction, the user can create their own concepts. We also have, they also present a special class that is the one that is down below here, that is called the strategic visualization. And this is a complementary visual representation in the analysis, development, formulation, communication, and implementation of strategies and organization. These are more in the domain of storytelling, and we can do some projections and predictions based on this type of visualization. The other type of visualization they present us is the metaphor, and basically using visual metaphors in order to create the data into a mapping that is easy to understand. And we saw one example when we were looking into remember the diabetes infographic. They were using the metaphor of the apple for the diet, and the pills for the medication, and then those things allow to map the data that we want to represent. And they have the compound visualization, where we have different representation formats in a single scheme or frame, and in that domain we are going to have the dashboards, but we also have other type of representation. Then let's explore some of these and talk a little bit about the different methods. And as you see, then the ones that are in blue, they call that process visualization. Then basically they depict a temporal sequence. It could be a stepwise, a cyclical, or a continuous sequence. And the ones that are in black, there are conceptual relationships as hierarchy or networks. There is no time involved, or there is not continuity involved in them. They are just pinpoint observations, but in the blue ones there is some kind of concepts. Also, the ones that have the sun, they provide an overview of the data, and the ones that are with the square, they provide detailed information about the data. And the ones that combine both things, the sun and the square, then they have detail and overview. And they have also this symbol on the top that they talk about the divergent thinking is when you can create new ideas, and the convergent thinking is when you come to reduce the complexity and try to create some synthesis. Then, as you see, these are other elements that are going to help you to decide what are going to be the best practices when you want to implement. It's not only the task. Now we have defined the task, then it's going to be a comparison. It's going to be a classification, is going to be a flow. What we want to do, but it's over time, or is a pinpoint. We want to do an overview, or we want to do details. We want the people to increase the thinking, or we want the people to synthesize. Then the radar, we have talked about them. Usually we have multiple observations that are going to represent the radials of the radar, and the units of observations are the ones that are going to be defined by the areas, and those areas are are created by representing the data points in every single axis, and then we create these shapes, and in that way we can see which observations cover more area, or where we have different behaviors of those areas. It's not really common in healthcare to see this type of representation, but it allows to compare, for example, phenomena, and you have different dimensions of the phenomenon, and see if the phenomena are look alike or they look different. If the overlapping is a lot in these dimensions, then we can say that they are look alike. This is basically like area chart that has been wrapped around the 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 x-axis, and the axes are made radials, and the values are in those radials. The other important thing that we need to have is that every single variable needs to be in the same scale, because in that way we can have the circle, and it's going to do to make more sense, because if not, the shape is going to be a little bit weird. Parallel coordinates, we have seen this before, and this is going to basically show us the line is the individual observation, then every single line is a behavior, and then we see who is behaving different than other ones. These are trees. These are hierarchical relationships, where basically you have relationships with observations and how they are created. Cycle diagrams, they are similar to the continuum, but they are representing concepts and how concepts feed them back, and for example the cycle of disasters, or the cycle of epidemiology, or the cycle of infection diseases. Those things usually are represented in these ways. Timelines, we have discussed timelines, and we introduced that before, and basically we have a sequence of time, and then we represent where different events are occurred, and when we can identify relationships between those events and the different categories. The Venn diagram, we learned that when we were studying basic concepts of math in elementary school, and I have used this a lot to represent some of the concepts, and how intersections and how different observations can interact and create new concepts. This clustering analysis is similar to this to the hyperbolic tree, with a difference that you don't have a central relationship necessarily. Flow charts, when you have processes, and they are a complete defined notation for flow chart, but it's an excellent way of representing a process, and usually has a start and an ending, and every single graph that we have there, block that we have there, has a meaning. Then the diamond represents a decision, the rectangle represents a process, the parallelogram, it's not the parallelogram, the quadrilateral represents a data acquisition. The D shape, it represents data storage, and the pentagon that is pointing down represents that the process continues in other place. And there is a whole language that is created and standardized to the flow charts, but they allow us to see a lot of process, and usually guidelines are represented as flow charts. And decision making process and processes can be represented in that way. A Petri net, it's another representation that allow us to do some calculations, and usually is informed by probability. And when we are doing risk analysis, or when we are doing Bayesian analysis, the probability of an event to occur, we can represent probabilities of event to occur given that we have another event as this type of networks. I already introduced you the relationship representation of data, but there is an entity relationship diagram. There is a formalism in the way that we represent those relationships, and then we have the different tables, we have the different fields or variables, and then we have the relationships. This is information lens. This is a little bit more complex, but you have different variables in the columns, and as you see, you have values presented in every single cell, and it's a multi-dimensional, like small multiples that we have there, but this allows to go from year, quarter, product, channel, region. Is just decomposing the same data in different observations. And then we can do this for epidemiological analysis, for example. Then we have, hey, what is the amount of death, how that death compares by quarter, what are the causes of that death, and what was the region where that death was occurred, and things like that we can do. The Sankey diagram or the flow diagram, we introduced the one from Napoleon, but there are some historical diagrams as well in public health, and this is allows to see how an initial state of distribution changes over time over observations, and then how the category or it moves in different ways that we observe things. In this case, it's electrical, is energy, and at the right we have the distribution who uses that in domestic industry, service, and transportation. And then on the left we have the sources. Then we have coal, renewables, nuclear power, natural gas, and oil, and the oil that is imported and the one that is refined. And then you see then how that oil is distributed domestically in industry, services, or how the coal or the nuclear power or the gas is used to generate electricity. That as intermediate, or some of the oil also goes to produce electricity, and then how we distribute electricity among the different sectors, or how we use natural gas to generate power in those different sectors. Then this is really interesting because that allows us to see how are distributed, and we saw a lot of these diagrams in the COVID dynamic, and how the different strains of COVID were being distributed and allocated, where it was identified and where they were affecting in the world. Data maps or choroplets, we have been talking about them a lot, and we will continue talking about them. The tree maps, this is a representation of part of a whole, where you just have subcategories, and then you start analyzing that data in that way. The cone tree, It's not that much use, but as you see, it's an interactive visualization. You have some variables on the left, and then you have some variables on the right, and they have a special projection or representation of the dynamic of the problem. System dynamics, this is another notation just to represent processes and how things changes and to create simulations. Or also we can use this type of elements to actually program artificial intelligence. And there is a concept that is called state machines, and we can represent state machines in this way, and computers can simulate events and change the states based on the interaction, and every single arrow is a change of state, and a new node is a new state of the system. Data flow is similar to the flow chart or the system dynamic, but this is basically has relationship of documents and places, and how data is interchanged between them. The semantic network that I already introduced a little bit as one way of data representation, and is also a way of visualization. And if you have a study ICD-10, the International Classification of Diseases, there is a way that we can represent that as a semantic network. But also in healthcare, we have a huge semantic network that is called UMLS, Unified Medical Language. And we have another one that is SNOMED-CT, that is the codification system to try to understand the meaning of the written medical English and how things are related. Then we can create that type of relationship of concepts, and we can do textual analysis in this way. And as you see here, you can start seeing some relationships and some clusters, and you can graph the strength of the relationships and the frequency of that. Mind maps, representation of your understanding of the world. They are really useful for collecting and transmitting ideas. They could be collectively built or individual built, and they could be highly interactive. Square of oppositions is similar to the two-dimensional Cartesian that we were presenting about the position of ideas. The mind to pyramid technique is really useful for doing a causal analysis, and then create three problems and depicting a problem, trying to understand the causes. And we can have another pyramid on top and then propose solutions, and that's a research methodology model that is out there. The synergy maps is a cycle that creates interactions between their elements. It's not that common use in healthcare. Force field diagram, then different elements that are influencing a problem. These are more conceptual representations. This is the cause-effect chains. Is different to the mind to pyramid, because this is are elements that are going to create a product, while this is a cause and the different effects. But you can combine both, and then to have a problem tree representation. Concentric circles, this is a hierarchical representation of data when you have contained data within other ones. The argument slides, then, hey, what are the fundamentals, what is your claim, and what are the facts sustaining your claim, and what are going to be the consequences. This is more an strategy to storytelling that we can use. And if we want to have an hypothesis, then we can have the facts, what are the conditions that apply to actually come to that claim, and what are going to be the future consequences. A toolme map is just a map of relationship. Is a similar formalism. Is a similar to the mind map, just that it follows a formalism. And the IBS argumentation map has also a notation that is similar to a mind map or a influence diagram. A meeting trace is a way of documenting meetings, as it says, and then just representing that sequence of events that happen and representing ideas. A communication diagram is similar to the workflow data. A flight plan, it has it's not follow really a flight plan. The flight plan representation, the real one, is a little bit different, but it has something that is starting, racing, flying, turbulence, the difficulties, landing, and after landing. Just to be aware of different project stages and what we need to do in kickoff, when we are developing, when we are there, how we manage problems, and how we are going to be closing things and what to do after closing. But for project management, we usually use is the Gantt chart that is based on activities. And if you see, this is a lifeline that has some precedence and relationships or hierarchy relationships there. The critical path method is a visual representation of, you have different ways to achieve a goal, and you have the weights of every single path. Then you can optimize your process to achieve the goal. And this is also an artificial intelligence method for training systems in order to identify optimal solutions. And when you have, for example, a navigation tool to arrive to a place, is using a critical path method algorithm. The swim lane diagram, this is a process diagram that basically is divided by some lanes or some columns, or it could be some rows that represent like a swimming pool, and that's why the swim lane. Then every single lane represents a organization, a sector of organization, or a process. This is another formalism that the process event change is similar to the workflow and the unified representation model of programming. PERT, it's another representation of conditional representation. This one has some transformations or weights on the cost of a decision. Then you can combine the probability and you can combine the critical path method in order to optimize frequency. This is really useful in presenting or analyzing financial data in healthcare and doing cost analysis and things like that. Metro maps, these are simplification of maps. The temple is basically representing the fundamentals, the principles and what we are supporting, or story templates about castles or different things. Then now you see that we are in the metaphorical or the three representations, or the funnel, or the bridge. We are just using the iceberg common concepts to try to convey ideas. And one visualization tool that is based on metaphors is Prezi. If you have ever used Prezi, Prezi fundamentally is a metaphorical visualization tool, and then you use metaphors to tell stories that are going to be presented to a public. And these are the integration that are the different infographic of visualizations, where we have the graphic facilitation that is an extension of the mind map, but you can have cartoons, you can have the rich pictures, the maps, the infographics, and all this kind for representation. And these are those special cases that are for strategic planning, and that basically they borrow from the previous representation and the previous algorithm, and this is the one that I was trying to explain you before, the magic quadrant, that you have those variables and you want to be basically in the right top side. Then and one of the fishbone of the Ishikawa is one of the best tools that we have used in causal analysis and root analysis when we have problems in healthcare, when we have adverse events, when we have unexpected events. Then we usually use a fishbone diagram to try to understand the cause analysis, or to represent the cause analysis of a problem. Then we start from the right, representing, hey, this is the outcome, and then we start researching the events backwards to try to understand what happened in order to produce that outcome. Technology roadmap is similar to a Gantt chart, but it has a combination with the swimming lanes. And you can name, you are going to see that there are a lot of representations that we are going to have there. Then if we are going to say that what is the ideal representation that or the ideal visualization tool that we should be using, the answer is always it depends. It depends on the task that we have on hand, and it's going to be depending on the data that we have. Then as a summary, definitely we need to define clearly what is the task, what is the story, what is the mission that we have. And in that, the next thing that we need to do is to organize our data in such a way that we actually can approach that task. And then select the best visualization that are going to be informing the task, that are going to be informing the story, that are going to be informing the questions, and we need to define the level of interaction that we want to have. I have provided you, and we have come through different representations and different recommendations, but there is no rule of thumb. I have been telling you since the beginning that there is no rule of thumb for a perfect visualization. It's going to be always tailored for your particular task, and it's going to be depending and constrained by the type of data that you have available. And with that, then you do your best in order to select the right visualization and to facilitate interaction. Thank you very much for your attention, and see you the next time.